Welcome to Broadpeak and VMware's demo, Orchestrated CDN Scalability for Streaming Performance. In this demonstration, you will see how Broadpeak Open Dynamic and Elastic CDN, or Broadpeak ODE, works together with VMware Telco Cloud Automation's multi-layer scaling to deliver a solution capable of increasing or decreasing the number of streaming servers based on real-time traffic conditions. The principle is simple and effective. Broadpeak ODE CDN, composed of streaming servers and a management function, provides service to a certain number of users. When the number of connections reaches a defined threshold, Broadpeak CDN engages VMware Telco Cloud Automation's multi-layer autoscaling function to deploy a new streaming server, and thereby increase the capacity of the CDN accordingly. Let's now go through the different steps of the demo: instantiation, scaling up, and scaling down. Our field network is composed of a core data center site located in the city of Groningen and an edge site in the town of Hoogzand, both in the Netherlands. These sites have been architected to run Kubernetes clusters on VMware Telco Cloud Platform and host all the Broadpeak ODE CDN components. The core data center sites cluster hosts Broadpeak BK S350 Origin, which packages and encrypts the video content, while the edge site is home to the following components. First, Broadpeak BK M100 Video Delivery Mediator that manages topology, allocates streams, and monitors the system. Then we find Broadpeak Operator, the module of the Video Delivery Mediator that triggers scaling procedures through VMware Telco Cloud Automation's open APIs based on business metrics, such as the number of streaming sessions. Finally, we have Broadpeak BK S400 streaming servers, caching and streaming the content. The complete setup infrastructure is orchestrated by VMware Telco Cloud Automation, which also oversees the orchestration of container-based applications as well as the scaling of streaming servers. Our first stop in the demo is the instantiation of Broadpeak's components using VMware Telco Cloud Automation. The onboarded components are available on VMware Telco Cloud Automation's Network Function Catalog. For demo purposes, we instantiate Broadpeak BK S350 Origin Packager by selecting the function from the list and clicking on Instantiate. After providing the instance with a name, we choose to deploy the packager in the central site's Kubernetes cluster and according to the packager's specific Helm chart. Then we load the packager's values file and we launch the instantiation. Similarly, now we instantiate Broadpeak BK M100 Video Delivery Mediator, but this time we choose to deploy it on the edge site's Kubernetes cluster. We associate the corresponding Helm chart and load the values file, containing, among other values, the mediator's analytics configuration parameters. The operator is then deployed through the same process. Since the latter is a module of the mediator, we select the same edge Kubernetes cluster for deployment. In this case, the operator's values file contains information on how to access VMware Telco Cloud Automation and APIs. Finally, we create the initial instance of Broadpeak BK S400 streaming server in the same edge site Kubernetes cluster where Broadpeak Mediator and Operator were deployed. After a few minutes, all the components are instantiated, and VMware Telco Cloud Automation's Inventory tab shows a single Broadpeak BK S400 CNF instance running. Now is time to verify that Broadpeak streaming service is also up and running. The Video Delivery Mediator's GUI shows one point of presence, or POP, in its topology, with the initially deployed streaming server online. The streaming server's front end shows a healthy server with no sessions serviced at this time. The final check in this verification process consists of visualizing a video stream. To do so, we connect a Dash video player to test content. Note that every video player first contacts the mediator and then is redirected to the appropriate BK S400 streaming server according to the workflow of the solution. With the streaming service activated, let's increase the number of streams to see the scale-up taking place. As configured in the Video Delivery Mediator, we can see that when the number of streams reaches 4, the operator triggers the instantiation of a new BK S400 streaming server pod. VMware Telco Cloud Automation's Network Functions tab shows a replica being created. With the scale-up process completed, the Inventory tab displays the newly created server. The first instance of the streaming servers shows our 4 streams connected, while the Mediator's GUI now reflects a second streaming server deployed. Since we have configured 5 as the maximum number of sessions handled per server, when a 5th session request arrives, the Mediator redirects it to the first streaming server instance, and then activates the second server to handle any upcoming session. We now activate an additional stream to verify that it is being handled by the newly deployed server. The Mediator's GUI shows this new session appearing in the second streaming server. Our automated scale-up process was a success. Now, let's decrease the number of active streams to scale down. As we begin to close Video Player's tabs, the sessions are cleared from the Video Delivery Mediator and BKS400 servers, while the operator triggers the deletion of the no longer required BKS400 streaming servers. With the scale-down process completed, the Inventory tab of VMware Telco Cloud Automation's GUI shows that the replica has been successfully deleted. Our automated scale-down process was successful. In this demo, we have shown how Broadpeak Open, Dynamic, and Elastic Container-Based CDN harmoniously works with VMware Telco Cloud Automation multi-layer orchestration capability to automatically adjust CDN capacity according to the demand. Thanks to Broadpeak ODE CDN's actionable intelligence, the infrastructure resources allocated to streaming are used only when needed, reducing cost and energy consumption.